then this diagram shows the deployment of expressway series in multinational environments. So this is just from design standpoint that how we can have expressways placed in deployment. So the question is, why do two expressway server needs to be neighbored together? So consider this example, which shows a multinational company with offices around the world. So how do you deploy the expressway series in this environment? So you could either have a single expressway C in one location. For example, let's suppose this is in Texas with all the devices registering to Expressway C. This deployment is centralized model and is simple to deploy, but the problem is the amount of traffic which is traversing the WAN and the delay in setting up a call. So here we can see if even if the call is happening between the two sites, for example, let's suppose these two locations, let's suppose one is in Sydney, other is Singapore. Every time the signaling has to traverse the WAN to Texas, the centralized point, and then from there back to the other site. So this will be a lot of WAN traffic and delay. So that is not an efficient solution. So then as alternate to it, to deploy Expressway C servers, depending on the number of devices you could deploy per country, per region, you can have a different type of deployment, which is this, which is called decentralized deployment. So having Expressway is on separate sites individually, and then between these sites to make the call routing, we can have neighbor zones. Then about the dial plans. So when looking at dial plans, you need to take into account the architecture of Expressway C servers. So this is again from the design perspective that there is a centralized Expressway C architecture here with a flat dial plan. So we have discussed about the problems with the centralized deployment, but along with the centralized deployment, if there is a flat dial plan structure like here, we can see all these numbers kind of similar. So these can have issues at the time of routing and or at the time of search of the destinations where we use search rules and so on. So it's better to use different structures. So that is called the more efficient and structured dial plan, and this is called a flat dial plan. So here we can see we have a centralized deployment. So we have Expressway C only at one location like New York in the headquarters. Each device has its own unique number or alias and everything registered to the single Expressway C here. The problem here would be that if you will get unnecessary traversal of traffic across the WAN and also a single point of failure. If there's an issue with the connection to New York office and the whole organization loses the communication network. So then we have as a solution another dial plan. So here you can see a complex video network with again a flat dial plan where you have Expressway C in each location and they're neighbored together to provide resiliency, redundancy. With this dial plan, you will need to search all sites to identify where a device is located. So for example, if you're dialing from Singapore, and let's suppose we are dialing from Singapore to New York. So you will you will send a search request to New York, London, and Dubai, all the neighbors. So like that happens in the case of routing protocols. So all the neighbors get the queries and they try to resolve and then answer with the reply, and whoever gets the destination route, it will take that path. So that is the route lookup and the time taken for that. But in this case, it will work the same way, but there will be a drawback to it that if it does not find it, and then it will send a search request to the other location and it will keep on happening, and that can create a loop between these expressways. So to avoid that, we have a loop detection mechanism between the expressways that works especially when you have neighbor zones. So then if you have multiple expressways connected together via neighbor zones, so loop detection mechanism is there. So Expressway have this feature enabled. You can enable that, which use the concept of search tag to prevent loop. So if a search tag is received, and if the same search tag is received again by an expressway, it can ignore it. So for example, if a call is made from an endpoint that is registered on Expressway A to an endpoint on Expressway D. So what will happen? It will send the request to all its neighbors to search. So it will send the search request to other Expressway servers. Expressway B will search its local zone, and if it does not locate the device, it will send a search request to Expressway C and D. C, let's suppose, now has two search requests for the same device. The original request from Expressway A and the second request from Expressway B. So without loop detection, what would happen? Expressway C would do a local zone search for the device for each request. And if it does not find it, it would send a search request to Expressway B and D back to those expressways. And this will create a continuous loop. So there is a loop detection mechanism which prevents this
Yes, yes.
continuous loop by using the search tag.